Hello, welcome to this e-training module. We're actually going to be looking at part 4 of the site selection scenario using the spatial modeler to create a standardized methodology for performing a site selection. In previous modules we looked at the basic use of input raster layers for the site selection. We used a land cover classification to look at a buffer around water areas that had been classified from satellite imagery, as well as forested areas that we wanted to build within, and also to use a digital elevation model to look at slopes. And then we looked at adding a standardized way of attributing your output raster data. However, as we'll see in a second, land cover classification doesn't always pick up all water sources. If you're classifying a coarser resolution dataset, you may only identify larger rivers and large water bodies, lakes and so on. Small streams and smaller rivers may not be identified. So what we want to do is actually use a vector data source of water courses and go ahead and buffer that as well to the 150 meter distance and use that as part of the criteria. So we're going to demonstrate adding some vector feature processing to our spatial model editor. So let's take a look at what I mean. Here I have the land cover classification displayed, and as you can see, you've got large water classes, larger water bodies, smaller lakes and so on, but no streams. If I turn on the vector layer, you can see the additional water sources that this will add to our site selection, that we need to build our barracks within a 150 meter buffer zone of a source of fresh water, and adding the streams, the vector streams, into the equation will hopefully add a lot more potential sites to our analysis. So I've gone ahead and cleared the contents from the 2D view. Let's go ahead and start the spatial model editor. Do it a little differently today. I'll go to the toolbox tab this time, click on the spatial model editor button to close out that 2D view, just to give us a nice large canvas to work on. And what I'm going to do is open the model that we prepared earlier in previous e-training modules, just to show you what we have so far, basically bringing in a land cover classification to look at the water extent from the land cover, and also DEM for looking at the slope, and also the forest canopy from the land cover classification. As I say, that might not be as accurate as we want it to be, so we're going to bring in that streams dataset as well and buffer that by the similar 150 meter distance. I'm going to go ahead and disconnect the preview at the moment. Let's go ahead and bring in a features dataset. For that we need the features input operator. Go ahead and double click on the file name and select my streams shapefile, which is on my recent list, or I could just navigate to where it is and select it. Then what we want to do in this instance again is do the buffer operation, which, if you remember from the previous modules, was a raster function called search. If we're looking at features though, we actually have a dedicated features-based, vector-based buffering operation. So we can bring the features into the buffer zones operator, double click that, and I want a 150 meters buffer with rounded ends away from all the streams. Let's go ahead and connect that up to my preview operator and click preview. That's going to read all those streams in. Go ahead and do a vector buffer. If we zoom in, you should be able to see all my buffer zones around the datasets. At the moment we've just got overlapping in, zones around each line. We could use something like merge features to merge these into one continuous polygon, but because of the next step we're going to do, we don't actually need to do that at this point. Now, because we are going to combine these buffer zones, this information, with the rest of our water and our raster processing, we might as well go ahead and convert to raster data at this point. So I'm going to bring in a convert to raster. Just disconnect the preview. Go ahead and connect that up. And turn on the hidden ports on that particular operator, and we can either double click the port, type in a value right here, or use the nudges, or I can come down to the properties panel, type in there, double click, whatever I want to do. So I'm going to say, okay, that those vector buffer zones, I'm going to convert them to a rasterized data set with a 15-meter pixel resolution. The output from the convert to raster will be locations that fall within the buffer zone, and then everything else will be no data. So if we want to combine this information with the rest of our analyses and not accidentally set those locations to no data as well, we need to convert the no data back to valid values. So we're going to use a replace no data with, connect that up and fill the no data locations with a value of 0. And then kind of the final thing we do for this set of water buffer operations is actually go ahead and turn it into a binary yes no. So in this instance we want a not equals. So at the moment from the replace no data with, we'll have the converted buffer zones, and those will have converted based on record number because I didn't change the defaults. So I'll basically now have zeros, which is everything apart from the buffer, and then an increasing value for all the pixels that fell within the buffer zones. So basically what I can say is anywhere where my output does not equal a value of 0 basically indicates an area that is within 150 meters of a stream location as input by the vector streams dataset. Let's go ahead and quickly preview that just to make sure that we're getting the right answers. Connect it up to the preview operator, click preview, and yep, that looks pretty much like a buffer around my stream vectors. So let's turn the preview off, get rid of that viewer. That's actually going to delete the preview. So really we now have two sources of water locations, or locations that are close to within 150 meters of water sources, and that water source is either coming from the land cover classification or it's coming from my vector streams. And we need to combine these two sets of possible close to water criteria. So I'm just going to move the rest of my model over a little bit to give myself room to operate. And what we're going to do is effectively create an index. We're going to use the add operator to add these two binaries. So I'm going to take that off of that logical and combine these two. So we've basically got two binaries being added to each other. And what we will have being output from the add operator is a 0, a 1, or a 2. A 0 indicating that neither this input nor this input were true. Neither were within the buffer distance of water. If it's a 1, that would indicate that one of them was true. One of them was within the 150 meters of a water buffer zone. And obviously if it's 2, then both are true. They were within the required extent. So we can turn that back into a binary. Let's actually select our not equals, make a Control-C, Control-V to make a copy of it, connect that up to what we currently have there. Again, I'm going to just shift these out of the way a bit. So now we've done a not equals 0 again. So again, we're going to have that true or false situation. The 1s and 2s are going to get turned to true, and the 0s remain false, 0, that they are not within the buffer zone. So now we're back to having a result that is a binary yes no within the water 150 meter buffer zone. So let's go ahead and reconnect that to the logical AND. So we've got within the 150 meter water buffer zone, and it's a forest canopy. And then the second logical AND adds the AND it must be a slope less than 1 degree into our analysis. So let's actually, I probably shouldn't have deleted the preview. Let's go ahead and hook that up. We could go ahead and run. Let's actually go ahead and save the model. Let's do a file, save as, spatial model as. We're going to call it barracks model with streams added in. Go ahead and replace the one I already had. And we also want to make sure we create a new output. So I don't want to, I'm going to go ahead here. I double clicked the file name port of the raster output, so I can now name my barracks with streams. That's going to be my final result file. And let's go ahead and actually run it rather than previewing. So let's go ahead and run that analysis. It's produced the output. Let's go ahead to our home tab, add a view, create a new 2D view. Because I just defined barracks streams, it should be on my recent list from file recent. Go ahead and click on barracks streams. And there's our new attributed and color coded data. See if we can add my original land cover classification in as a backdrop. Put the streams on top, or not the streams, our new locations. So now you can see we've got a lot more of the magenta color class being added in, even though they're now a lot further away from the land cover water bodies. They must have been close to the streams, so we could actually add the streams on here as well. Yep, sure enough, these ones are within the buffer distance of this stream network, and are on shallow slopes, and are in a forest class. So let's go ahead, we can close that off, zoom out a little so you can see the entire model. And there we have it. There's our final site selection analysis, combining both raster information inputs and vector information inputs, and performing a GIS analysis to find suitable sites. Thank you very much for watching this e-training video. Hope you enjoyed it, and please watch some of the other ones that we have. Thank you very much.